Good morning everybody. I am going to take Architecture of 8085 microprocessor. This is from JHD, Department of Biomedical Engineering, working in SNS College of Technology. Let us see the content in detail. That is, we are going to see the introduction, block diagram, registers, memory, instruction set, timing and control signals, instruction execution cycles, interrupts and applications. Let us see the key features. It has 8-bit data bus, 16-bit address bus, registers, memory, instruction set, timing and control signals, accumulator, general purpose registers, interrupts, program counter and stack pointer. Let us see the architecture of 8085 in detail. This is what the architecture of 8085. Here the 8-bit internal data bus, the accumulator, temporary register, flag register, instruction register, ALU, instruction decoder and register select and address decoder, timing and control, address buffer and data bus buffer. Here the timing and control, the overall timing and control circuit is controlled by clock, ready, read bar, write bar, ALE, S0, S1, IO slash M bar. Here IO slash M bar is nothing but input, output or memory. If the pin is low, the memory is activated. Hold and reset. Next one was instruction register. It stores the opcode of each instruction. Next one is instruction decoder. The instruction decoder decodes all the instruction which are stored in the queue. Here the WZ, BC, DE, HL register pair. And A accumulator is nothing but it performs the overall function. Interrupt control, INTR request, INTA and RST 6.5, 5.5, 7.5 at last track. And serial output control, SID, SOD. Address bus buffer and data address bus buffer. Here data bus buffer is multiplexed with the address bus, or address bus is higher order address bus. Register, general purpose register. It has 8-bit address A, B, C, D, D, E, H, L. The general purpose register, temporary register, special purpose register. General purpose registers are the A, B, C, D, E, F, G, H, H, L, F. And temporary registers are W and Z. Special purpose registers are accumulator, flag register, instruction register. 16-bit registers are program counter, stack pointer. Here the program memory, number one, the data memory and IO memory. Program memory is nothing but the program, the data are stored. That is, the program is where the instructions of the program are stored. The program memory in 8085 is generally organized by ROM or RAM. Data memory, it is used to storing the data during the program execution. It is typically organized as RAM, allowing read and write operations. The data memory is accessed by using the general purpose register and the memory address register. Next one, IO memory. It is used for interfacing with input and output devices such as keyboard, displays and peripherals. It is organized as a separate memory location, with each location correspond to the specific IO devices. Instruction set. So it contains the 5 instruction sets. That is what? Data tab set codes, arithmetic and logic instruction, branching and looping instruction, stack and subroutine instruction, control and interrupt instructions. Timing and control, read bar, write bar, read and write, memory and input, output, request, reset, ready, hold. Address bus, the address bus carries a memory address, data being accessed as a IO port address during the data transfer. The data bus buffer carries the actual data being read from or write to our memory or IO devices. Fetch. In this step, the microprocessor fetches the instruction from the memory point out to the program counter. This PC is incremented by 1 after the fetch instruction. Decoder instruction. Once the instruction is fetched, the microprocessor decodes it to determine the operation to be performed and operations involved. Execution. In this step, the microprocessor performs the operation specified by the instruction on the operands. Finally, the result of the execution is stored in the approximate memory location. That is what fetch, decode and execute. Next one is what? Interrupts. So interrupts are the signal generators that are connected by the external devices to request the microprocessor to perform a particular task. There are 5 interrupt signal: trap, RST 7.5, RST 6.5 and RST 5.5, at last INTR. Trap is a non-maskable interrupt, whereas next highest priority goes for RST 7.5 and next highest priority goes for RST 6.5. At next one goes to RST 5.5. At last INTR request. It is a maskable interrupt that is generated by the external device such as a keyboard or mouse. it has the very lowest priority. And the STAP is nothing but the highest priority. It cannot be disabled by any other input. Application: WordStar, automatic water level controller, automatic plant irrigator, and traffic control system. Thank you.